Hi, this is a geometry lesson, and it's on measuring angles, and it's in section 1.6 of your book is where the topic is dealt with. And so we're going to talk a little bit, first of all, about what an angle is. And an angle is composed of two rays. So if I have a ray here, let's call this AC, and then I have another ray here with A as a common endpoint, and let me label this as a B. So this is, sorry, that doesn't show up too well, but that's part of that ray. So I have ray AC and ray AB with common endpoint A. Then I have angle BAC, or I could call it angle CAB, but I need that common endpoint to be in the middle of my name of the angle, so the A here. We call that A, you know, where the common endpoint, we call the vertex. So that's the vertex of the angle. Now, we can measure angles by using a protractor. I'm sure you've done this sometime before in your math career. And so what we do, we take the protractor, we put this little mark here at the common endpoint A, and line up this bottom line with the bottom of the protractor here and this zero line here. Now some protractors are different. Some will have a little circle there, but you know, they all are basically the same idea. You have to find the point where to put the vertex there. And then this is an acute angle. We'll talk more about that later, but we're measuring from here. We go 0, 10. So these marks are 5. The numbered marks are every 10. In this protractor, every mark here is a degree. So 1, 2, 3, 4, 5 degrees. And in between are half degrees. Even if you don't have the half degrees, you can often estimate and measure to the nearest half of a degree. Now you notice that here it actually does come up enough, but it doesn't quite come up through the thing. So if you ever have that where your angle, your ray is too short, you can always extend your ray, because a ray obviously goes out infinitely. And so you can take your pen and extend your ray. Obviously don't do it in your book, but on a piece of paper you may. And then it's easier to measure there. And so as I'm measuring this, this looks to me to be 31, 32, 33. This looks to be about 33 degrees. Let me double check that. Yes, 33 degrees. So I could measure this as 33 degrees. Now some protractors, you know, have this little plastic thing that goes out like there. I don't like those, and I wouldn't get the things with the little plastic things. They don't measure as accurately. It's better to actually draw out and extend it. Now you'll notice there's two scales on the protractor. There's this one that goes 0, 10, 20 this way, and then it goes and then we have the other, this inner scale that goes 0, 10, 20 this way. Well, if I'm measuring, I'm going to measure other angles here. So I'm going to have an other ray, and this is going to be ray A, I'll call it AD. So this is AD. So if I wanted to measure this angle, it would be this measure that I would be looking for. Well, on that, if I put the protractor this way, I'm going to line it up again at the common endpoint A. I'm going to go out there to D, make sure everything's straight and lined up. And I can't go out too far here, but that's good enough. And then I can measure the angle here as 0, 10, 20, 30, 40, so forth, out to 147. So this angle is 147 degrees. You'll notice that I have a straight line here because these rays, both have this common endpoint, and one goes straight out this way, one goes straight out this way. And you'll notice that if I add these two angles together, I get 147 degrees plus 33 degrees is 180 degrees, and that's what I expect for what we call a straight angle. Okay, so this whole angle here is 180 degrees, and it's called a straight angle. And we're going to name angles a little bit more later. Okay, now I'm going to deal with something called the the protractor postulate. And the protractor postulate is on page 37 of your book. It's postulate 1.7. And I'm going protractor postulate. And the protractor postulate basically says we can have one angle here of OB, or one ray, I'm sorry, one ray of OB, and another ray along this line, the same line, and that's going to be ray OA. And we could divide this up into a series going from 0 to 180 degrees. And so, that's what a protractor does. So we can pair OA with 0 and OB with 180 degrees, and then divide everything else up. Now, the second part of it is that if I put in two other rays here, let's say OC, and let's say another one, again with the common endpoint O, let's call this one D. I can measure with a protractor both of those angles. Well, not the angles, but where these rays are. So this ray measuring from here is, I'm going to call it 31 degrees. And this one over here, measuring again using this inner scale, because that's where I started with here, measuring to, I'm going to call that 152 degrees. Okay, so this angle is this, 31 degrees. This angle all the way over here is 152 degrees, I said. Correct? Is that what I said? 152 degrees. And if I want to know this angle here, what I can do is I can take the measure of this angle COD as basically this measure here of 31 and this measure here of 152, and go 152 minus 31, and that is going to equal to angle COD. COD. So 152 minus, I'll put it here, minus 31, I get 1, 2, 121. Indeed, if I measure this, I'm going to measure it, I can move it around wherever I want to. I'm going to measure it this way, and indeed, going here to here, I get 121. Now, you can see in your book that the way they state it there, but basically that's the idea of the protractor postulate. Now, some other things here that you've had before, we can classify angles, and if we have an angle that is between 0 and 90 degrees, so between 0 and 90 degrees, so, and I'm just going to sketch it here, let's say an angle like this, so it's less than 90 degrees, greater than 0, so 0 is less than x is less than 90 degrees, we call that an acute angle. I remember that by thinking, well, it's a nice small little angle, it's an acute angle. If we have an angle that is exactly 90 degrees, we call that a right angle. Okay, and we usually put this little box here to indicate that this is 90 degrees. And if we have an angle x that is, I'll put x as our angle there, is between 90 degrees and 180 degrees, we call that an obtuse angle. I think it's a big fat angle, sounds sort of like obese, not to be politically incorrect, but sounds sort of like obese, so I think obtuse, obese, it's a big angle. And then I can have an angle that measures 180 degrees. Again, that's just a sketch. So this is 180 degrees, or x is equal to 180 degrees. So if this angle here, x, is 180 degrees, I have what we call a straight angle. Okay, some other concepts is we have what we call congruent angles. And a congruent angle simply means that the measure of one angle is the same as another. So if I have, angle 1 here, I'm going to call it, and I have over here angle 2. And if the measure of angle 1 is equal to the measure of angle 2, so for example, let's say this is 30 degrees, and let's say this is 30 degrees, and so the measure of angle 1 is equal to the measure of angle 2, I can also say that angle 1 is congruent to angle 2. Remember, this is the sign to mean congruent. The next part we have is on page 38. We have another postulate, and we call this postulate the angle addition postulate. So the angle addition postulate. And basically this says, and I'm going to draw it similarly to what is in the book and is in most books. I have a big angle AOC. So this is going to be A, this is going to be O, and this is going to be C. So that's AOC. And I have another ray with the same common endpoint, B, and I'm going to label this B. So I basically have 3 angles. I have AOB, BOC, and AOC. Well, the angle addition postulate is going to say if I take these two angles with the common interior ray here, notice they don't overlap, they just have this common interior ray. Well, then I know then that angle AOB plus, I should put the measure of angle AOB plus the measure of angle BOC is going to equal, so this angle plus this angle is going to equal the big angle here, AOB. So it's going to equal to the measure of the angle of I think I said AOB, I meant AOC. AOC. Okay, now the other thing, other part of this postulate, I'll move that up a little bit, is that if I have a straight angle, and so for example I have a straight angle and this is O, and so this is A, B, and C, that if I measure angle AOB plus the measure of angle BOC, that's going to equal to this whole angle, which was what we did before, but we also know that this is equal to 180 degrees, so it's going to equal to 180 degrees. Now, we're going to talk about some, and let's make sure everything's on there. Sorry about that, I chopped some of that off, but now you can see it. That the measure of AOB plus the measure of BOC is going to equal this straight angle here, the measure of this straight angle AOC. So that's a part of the angle addition postulate. I'm going to zoom out here a little bit too. Oops. Okay. Now, the next part of this lesson is we're going to look at identifying some pairs of angles. And these are, first of all, I will get here, and the first pair we're going to do is we're going to look at 2 intersecting lines here. And I'm just going to name these. I'm going to go 1, 2, 3, 4. And angles with 2 intersecting lines here, the angles formed that opposite each other, like angle 1 and angle 3, are called vertical angles. And the interesting thing about vertical angles is that the measure of angle 1 is going to equal to the measure of angle 3, or we can say that angle 1 is congruent to angle 3. Similarly, angles 2, I'm going to zoom in a little bit so you can see this clearer. Similarly, angles 2 and angle 4, so angle 2 and angle 4 are vertical. And we know then that the measure of angle 2 is equal to the measure of angle 4, or that angle 2 is congruent to angle 4. Now, if we have two angles on the same plane with a common side and common vertex and no common interior points, we call them adjacent angles. And that sounds fancy, but what it means is like I have an angle here, and then I have a common interior ray here. So let's say I call this, well, I'll just put in arrows here, and I call this 1 and 2. Angles 1 and 2 with this common interior ray are adjacent angles. And adjacent angles means just what adjacent means. It means they're next to each other. Okay? So those are adjacent angles. Complementary angles, and you've had this before also, I know, in like pre-algebra. Complementary angles let's see if we can get better without the light there. I think that's a little better. Complementary angles are two angles whose sum is 90 degrees. So I can have, so for example, if I have this angle here, which I'm going to say is 30 degrees. I don't know if it's 30 degrees, but I'm going to say it's 30 degrees. And then I have another angle here, which is 60 degrees. Because these two angles add up to 90 degrees, these two angles are complementary. Now, where you often see a complementary angle is when you have a right angle. So we're going to say that this is a right angle. And now we place a ray on the same plane with the same endpoint, an interior ray, and we're now going to have two angles. Let's call this angle 1 and angle 2. Well, angle 1 plus the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. So we say that angle 1 and angle 2 are complementary. Now, the other thing that we can have is two rays whose sum is 180 degrees. So we call these supplementary angles, and you've had this before also. So supplementary angles are two angles whose sum is 180 degrees. So, for example, if I have, and they don't need to be together, they don't need to be adjacent. So if I have this angle, which I'm going to say is 120 degrees, and I have another angle over here, which I'm saying is 60 degrees. then this angle and this angle are supplementary because they add up to 180 degrees. But where you often find it is you will have a straight angle, 180 degrees here, and there's the common endpoint for the two rays, and we cut this somewhere here, so we have another ray that is on the same plane and has that same common endpoint interior to these other rays, and I'm going to call this angle 1 and this angle 2, so angle 1 and angle 2, and then I know that the measure of angle 1 plus the measure of angle 2 is going to equal to 180 degrees, and I can also say then that angle 1 and angle 2 are supplementary. Now, the rest of that section is about working with the definitions we've gone through here, and the ideas, the concepts we've gone through. So I'm going to let you simply go ahead and do that, and I will put an assignment on the board for you. So with that, we will end this video.